Good afternoon. Okay, good afternoon, everyone. Now we will discuss next part of the chapter. So, in this chapter, just to remember, next concept is types of reaction. So, type of reactions again, four types of reactions are there. Even there are five types are there. So, even redox reaction. So, taken into consider. You can see here there is first type of reaction is combination reaction. So here we should discuss about again one more time what do you mean by combination reactions and all. Let's remember here. So types of just a minute, okay. Types of reactions. Okay. Types of reactions. First one is combination reaction. Combination combination reaction. So in this reaction, remember here A, A plus B gives rise to AB. So here energy is produced. Generally, these combination reactions are exothermic in nature. So So we can write type of reactions. First one is combination reaction. Okay, so in this combination reaction, remember here there is an reactant A combined with reactant B gives rise to the product AB. So you can see here two or more reactants. These are reactant, right? Reactants. Two or more reactants react to form a single product. Single product. Such kind of reactions are called, we can say, combination reaction. This combination reaction is also called a synthesis reaction. Another name for combination is synthesis. For example, we can take example like carbon plus oxygen is raised to carbon dioxide. So last class we discussed that. Again we have three type here. So one is element combined with one more element gives rise to compound. Example we taken carbon plus oxygen gives rise to carbon dioxide. Similarly, second one element combined with the compound. So in this case we get again compound. This is another type of combination. Example we can take carbon for the carbon dioxide forms carbon monoxide. Similarly, compound compound plus compound. Compound combined with compound forms again compound. Okay. So example we can take calcium oxide plus H2 gives rise to calcium hydroxide. This is an example for a combination reaction. And here, one more thing you remember here, this combination reactions are they are combination reactions are exothermic. Exothermic. So what do you mean by exothermic, sir? Exothermic means energy will be released. Energy will release release outside. This kind of reactions are called exothermic. Suppose we have taken example of calcium oxide combined with S2O gives rise to calcium hydroxide. Okay, so along with that, a large amount of heat energy is produced. Okay, you can see in the diagram Yes, you can see in the diagram they given here, combination reaction diagram you can see here. They given here, you can see in the this beaker they are taking the water and then added calcium oxide. They are saying vigorously calcium oxide react vigorously with the water and produce liquid lime calcium hydroxide releasing large amount of heat. So what I'm saying here, so combination reactions are generally they are exothermic in nature, means energy is going to be kind of energy we can say, not only energy. So generally they are exothermic in nature. So one more example, what we can take, calcium oxide plus CO2 gives rise to calcium carbonate. This is also a candidate example. This kind of reactions are called the combination reactions. Okay, and if you know very well, carbon plus oxygen gives rise to carbon dioxide. When we are burning the paper, so in that time we will get heat energy also along with that. So try to understand here, combination reactions are exothermic in nature. Okay. So one more thing, there are certain reactions are the example, what we can say generally in chemistry will say exceptions. Suppose we have N2 gas combined with oxygen forms 2NO. So these reactions generally occurs in the presence of lightning actually. So this is what you can say exception. This is exception case. Okay, so these kind of combinations are endothermic. This reaction is endothermic in nature. This is endothermic. Okay, so here generally in the atmosphere during the thundering, nitrogen gas is combined with an oxygen gas to form the nitrogen monoxide by absorption of energy. That's why we're calling it as endothermic. Endo means remember inside. Okay, this is only exception you can say. Inside, energy is absorbed. Energy is absorbed. This kind of reactions are called what's that? Endothermic. Okay. So now again some more examples we can discuss about combination reactions. Okay. Combination reactions. Mm, so we have examples like hydrogen gas is going to burn with oxygen to form water. Along with that, energy is going to produce here. This is also a combination plus exothermic. So there are certain exothermic reactions are there generally, which are those. So generally we can take respiration. So respiration is example for what's that? Exothermic. The respiration what happens is carbohydrate C6 H12O6 plus we are taking during respiration oxygen gas combines with this carbohydrate and forms carbon dioxide gas and H2O plus along with the energy is produced in this reaction. Okay, energy is produced in this reaction, so it is called exothermic. Okay, exothermic in nature. So reactions which produces energy out is called exothermic. This is about combination, and combination reactions are generally they are exothermic in nature. Just remember, okay. Now to come to the second type of reactions. So second type of reaction is we are calling as second type of reaction is decomposition. Decomposition reaction. So decomposition reaction is also called analysis. Analysis reaction. Okay. So कंपाउंड को ब्रेक करने के बाद एनालाइज करते क्या है कंपाउंड में, उसके लिए इस रिएक्शन को एनालिसिस रिएक्शन भी कहा जाते हैं. ओके. सो नाउ इसमें क्या होते हैं, रिएक्टेंट सिंगल रिएक्टेंट विल बी देयर, सिंगल रिएक्टेंट, but we write single reactant react reacts to form two or more products. Two or more products is called what's a decomposition reaction. Example we can take, we have AB forms A plus B. Okay, A plus B. This kind of reactions are called what's a decomposition reactions. Now take example. We can take example like so we have CaCO3 calcium carbonate. It is also called limestone. Generally, this limestone or it is also called marble, and it is called composition of eggshell also. And after what we can say, it's a different name. Just to remember, even you know very well, chalk also same formula. These are the different name for calcium carbonate. Just remember, generally in XYZ questions are there in chemistry. If XYZ questions, they'll give the hint for hint will be like this. Suppose XL is added to the sodium, sorry, dilute HCl. That I will ask you to discuss anyway. So here what we are taking the so here we are taking so here we are taking calcium carbonate. Okay, it produces calcium oxide and CO2 gas. Remember, the calcium oxide is a solid, and remember, this calcium oxide will be used in the manufacturing of cement. The last compounds X is produced, which is used in the cement industry. Then at X is nothing but what's a calcium oxide. This also called, you know very well. This also called what's a quick lime. So quicklime they will call, this is called limestone, remember. So anyway, this is what kind of reactions are decomposition reactions. Okay. So again, this decomposition reactions, this decomposition reactions are absorbing the energy, absorption of absorption of energy will take place here. That's why this kind of reactions are called decomposition reactions are called endothermic. They are endothermic in nature, endothermic reactions. Okay. Now, again, based on the what kind of energy they are going to observe, based on that, again, these are classified into first one is thermal decomposition reaction. Thermal decomposition means what, sir? Thermal decomposition means nothing but what, sir? This reaction will take place by the absorption of heat energy. Just remember. Okay. So thermal decomposition. So let me write equations. So I will take this color. I think right now it is this color. Thermal decomposition means what, sir? Actually, the given example is CaCO. Just now we taken this example. So CaCO3 will forms calcium oxide plus CO2 gas. Okay, this reaction is possible. So when we are supplying heat energy, so when we are supplying, I think the 373 Kelvin. Okay, so it forms calcium oxide and carbon dioxide. Here, what kind of energy is absorbed, sir? Here, heat energy is absorbed. Heat is absorbed. Okay. Okay. Similarly, take now we have second type of reactions. So generally, remember again I said again I'm saying this. There is a chance of this compound X. X is used in, okay, used in manufacturing of cement. What is X, sir? X is nothing but calcium oxide. So what kind of hint they can give about carbon dioxide, sir? That is an hint can be given about carbon dioxide is that this will be, and what they can use that they can give Y gas is produced. Y gas is produced, which which can turns what's that, lime water, lime water, what's that, milky white. Which gas will turn slime water milky white, sir? Milky white. Which gas, sir? Carbon dioxide. Or they can use, it will be extinguish the fire. So fire extinguisher. It will be used as a fire, used in a fire extinguisher. Which gas is used? So these kind of the hint they can give about carbon dioxide, and they can use calcium oxide. They can use in what, sir? They can ask like X is used in the manufacturing of cement, or what we can say, solution of where, solution of X used as what's the whitewash. So these kind of questions, this kind of int-based question they can ask about calcium oxide or carbon dioxide. This you should remember in chemistry. Especially in chemistry, we know very well there are more number of questions which are asked in terms of X, Y, Z questions. Okay. Now Now, one more example we can say about decomposition reactions, which is so we take so we take example of what we can take for example of iron sulfate. So this iron sulfate will be first iron sulfate will be undergoes decomposition. Remember, first reaction FeSO4 have a seven water molecules with them. Okay, this is called water of crystallization of iron sulfate. It forms first FeSO4 plus 7H2O. So here also decompositions. Here also we need to supply the heat energy. Remember, so first step. This is first step. It not mentioned in textbook, I think. So first step, what happens? FeSO4 have a seven water molecules along with them, and it is going to get separated when at the end small amount of heat energy is supplied to the this compound. Okay. So now afterwards again what we have FeSO4 on heating again we are supplying heat energy. Okay. So this Fe2O3 plus Fe3O3 plus what we can say SO2 plus SO3 gas is going to produce. Okay, here also we are supplying what's our heat energy, and this Fe2O3 is which colors are you know very well. Iron oxide generally reddish brown color compound is formed there, reddish brown color, and these two are the having smell of pungent. Pungent means irritating smell. And what is the color of these two, sir? These two gases are colorless. They'll ask the question. So colorless gas are produced, but they have the pungent smell, pungent odor. In chemistry, smell they will call as odor. Odor means remember nothing but smell. Which smells are pungent odor. Okay, pungent odor we can say. So this is also example for what kind of reactions are. This is also example for this is also example for what's a thermal decomposition reaction. Okay, so in this process, you should remember thermal means thermo means nothing but what's a thermo means heat energy. Okay, thermo means heat energy. So chemical reaction taken place by the absorption of heat is absorbed. Heat is absorbed, you can say. Okay, so this kind of reaction, thermal decomposition reaction. So second type of reaction is second type of reaction is called photolytic photolytic decomposition. Photolytic decomposition reaction. So here what happens here? Here also what's a single reactant? Single reactant will produce two or more number of products. Okay, in the absorption of by on absorption of what's a light energy. Example we can say they take an example of 2 AgCl gives rise to so 2Ag plus Cl2. Okay, absorption of what's a light energy. Remember here light means what's a so light is the photo means light. Photo means light. It's photochemical reactions. You know about photosynthesis, right? So photo means remember it's an light energy. Okay. So you see how many reactants are there? One reactant. Don't think about this two reactants are there. This is done for balancing. Okay. One AgCl produces one Ag and Cl2 gas. In the presence of what's a light energy. Again absorption of energy is taking place. That's why it is also called what's a endothermic in nature. And what kind of reactions are decomposition reaction. Okay, so photolytic decomposition reaction. Photo means remember what I said, light energy. So light energy is absorbed. Now see one more example we can say AgBr. So AgBr on by absorption of again light energies and the occurrence of sunlight produces Ag plus Br2. Ag plus Br2. So this is also example for what's our thermal decomposition reaction. Okay. Now here, one more doubt will be there for everyone, not everyone, it's 7 students. Okay. So one more doubt here. So what about photolytic? What about photosynthesis reactions? So here is a photosynthesis reaction. Let me write here. Photosynthesis. Photosynthesis. Photosynthesis is what, sir? Actually, there is an carbon dioxide and there is an water, and these two will combine. Okay, two will combine in the presence of what, sir? Sunlight means light energy. Where, sir? Where in the chlorophyll. In chlorophyll, what happens, sir? C6, C6, H12, O6 plus O2 plus transpiration S2 will form. What about this kind of reaction? Is a decomposition reaction or not? Answer is no. No, not decomposition. Not decomposition. So why, sir? Why it is not decomposition? See here. This reaction may taking place in the presence of light energy. But here, how many reactants are there, sir? So two reactants are there. Two reactants are there. What is the condition of decomposition, sir? There must be an single single reactant should be there. Single reactants. Okay, that's why this is not a decomposition reaction. So there may be a question why sometimes they'll ask why this what's that photosynthesis is not a decomposition reaction. So why? Because you see here two reactants are there. Condition the single reactant should be there. Okay, and how many products are there here, sir? So here it is going to obey the what you call decomposition because more than one products are there. Anyway, this reaction is taking place sunlight, but how many reactants are there, sir? Yeah, two reactants are there. That's why it is not what's that? It is, we can say it is photochemical reaction. It is called photochemical, photochemical, or we can say photolytic. We can say photolytic. Okay, photolytic I can say, but not decomposition, not it is. Okay, just remember. Okay, then after you see next. So they given the uh, so remember here one more thing I forgot to say. This compounds are the like AgCl and this not AgCl2 AgCl AgCl silver chloride and AgBr. Okay, these two things are used in the what's that? Photography. Substance which are used in photography. Okay, which reactions are decomposition reactions. What kind of substance they are using, sir? AgCl. They will use decomposition reaction of AgCl, AgBr. What kind of photography? Remember, black and white photography. Black and white photography means that speaking that like talking about what's the AgCl and AgBr. This please remember. Okay. Now, now after we can see one more question they asked. Just I'll say for people. They asked a question that they asked that AgCl turns into silvery gray. What is the reason, sir? You remember, we know very well, AgCl gives rise to Ag plus Cl2. So given option A, decomposition of Ag and Cl from AgCl. Option B, decomposition of Ag from AgCl. Option C, decomposition of Cl2 from AgCl, something, some other options. You see, the given word silvery gray. Silvery gray because of what, sir? Because of what, sir? Silver. That's why I should choose the option, this option. Okay, that when we will discuss MCQs also afterwards, completion chapter and all. In this, these kind of questions, they will make you people to get confusion. Okay, so there should be an clarity in CBSE. Maximum CBSE people will ask clarity. Remember, clarity is important there. Okay, so next reaction, next type of decomposition reaction is photolytic completed. Next, last one is thermal completed. I can discuss about electrolytic. So you know very well. So electrolytic, electrolytic decomposition, electrolytic decomposition reaction. So here what happens? Here they take an example of H2 gives rise to H2 plus O2 by supplying what's an electrical current. So you can see here one more important thing is here. So they given the diagram in textbook. You can see here it is an beaker. Okay, there is an rubber cork they given here, two rubber cork here, and here electrodes they given here. So sorry guys, I'm not able to draw it properly. So here they taken the H2O, and these two are connected to the battery. Okay, this is negative output and negative electrode it is. What will take a shapes better. Okay, now let me go through the diagram only. It is given in the textbook itself. Okay, we need to go further than separate diagram and all. It's a more difficult thing. Okay? So you can see in the diagram they given here. Okay, now you can see in this diagram. So what they given actually. Now see here there is an two electrodes are there, and we can see here this one. Just a second. Now see there is an here two electrodes are there. One, this is one electrode, and this will be the okay. Now see here there is an one electrode. You can see here electrode is there. Here one more electron, and this will be the negative electrodes. Remember this. Why? Because to connect to negative potential, that is called cathode. Remember negative. Cathode means cation means positive. Cathode means negative. So anode means positive, anion means negative. Okay. Now see they are given here two electrodes are there. Then after you can see they took the water here because we are doing decomposition of water actually by supplying it. Here there is a battery switch here, and you can see that two test tubes are there, which are kept invertedly upon the this electrodes. Okay, electrodes के ऊपर inverted में रख दिया. You can see here also. Okay, now they kept reverse. Inverted means reverse. Okay, so now there is an water. So just let me write reactions, what kind of reactions is taking place here actually. Hmm, okay, now see here there is an water. Okay, water is there, and what we are doing, we are supplying the electric current, right? So in that cases, water will split into H plus and O minus two ions. What answer? H plus and O minus two. So let me write reaction at cathode. So cathode, what happens? Cathode means negative potential. So cathode means negative potential means it will attract towards a positive ion. Okay. So what I can say? So here two H plus ions will come here and they will gain two electrons. So we'll give two electrons such. Let me see. First we write reaction at anode. So anode means it's an positive potential. Attract what kind of ions are negative ions. So here what I can say, two O minus two ions will come and they'll convert it into O2 and producing four electrons. Okay, here four hydrogens will be there. Four hydrogens will gain four electrons and they'll produce two H2 molecules. Two H2 molecules. You remember here again I'm saying here. So there is an two electrodes are the one is cathode, another is what's that anode, and this H2 when we are passing electricity to the water through the water, in that time two H plus ions will produce and one O minus 2 ions. O minus 2 ion will produce. Okay. So what I am saying here, this is anion. This is called anion. Anion किधर जाएगा? Anion anode के पास जाएगा because anode contain what's a positive potential. Positive electrode is called anode. It attract negative ion. Similarly, cathode electrode and attract what's a positive ion. Okay, this is called cathode. It is called cation. So cation will go near the cathode, anion will go near the anion will go near the anode. So should writing reactions at anode, positive potentialities, it is attract oxygen. So one oxygen atom ion will be there. Oxide ion will be there, which has minus two. One oxide ion carrying minus two charge. Such like two oxide ions will go near the anode that converted into O2, one O2 molecules, and one oxygen have a extra two electrons. So two will be two are there here. Two are losing two plus two four electrons. This four electrons is of gained by the four hydrogen atoms. Sorry, hydrogen ions which carrying plus positive ions. So four gains and two H2 will produce here. So this reaction. So where we can expect which gas is produced near the cathodes are which gas are hydrogen gas. Similarly, cathode means hydrogen gas. Similarly, which gas we can expect near the anodes are? We can expect which gas are oxygen gas. You see here how many hydrogens are produced here. So here for every one oxygen, there is one oxygen. For every one oxygen, so two hydrogens molecules are going to produce here. That's why I can see space is more here. So this space is less here. It means if it is suppose 2 ml or 2 centimeter cube space, 2 centimeter cube space. This you can see this side there is an only 1 centimeter cube. It means for every two hydrogens, one oxygen is produced. Why? This is only they will ask the question. First question they will ask what is a gas which is produced at the cathode means cation is what's the hydrogen. That's why near the cathode we can expect which gas are hydrogen gas. Here hydrogen gas here. Okay, near the anode which gas are oxygen gas. So oxygen gas will be at the anode, hydrogen gas at what's the cathode. Okay, so here so let me write equation here. Hmm, equation I write here equation. So I will write equation there. So 2H2 gives rise to what's that? H2 plus O2. H2 plus O2. Okay, remember why this is so? Because you see here, one water molecule is made up of hydrogen. Two hydrogens are there, and there is one oxygen. There is one oxygen. We can say hydrogen to oxygen ratio in water is what's 2:1. This is what number ratio. This is volume ratio or number ratio. Sometimes in the exam they will ask mass ratio. In the examination they will ask what's the mass ratio. So right here again water formula is H2O. So water is made up of two hydrogens and there is one oxygen. Okay. So two hydrogen mass is two unified mass and Mass of one oxygen is 16 unified mass. So we can say 2 ones are and 2 8. This is what ratio? So this is a mass ratio. So mass ratio, remember, mass ratio. What is the number ratio, sir? Number ratio is two hydrogens are there and one oxygen is there. That's the ratio will be what, sir? 2 is to 1. This is number ratio. This is number ratio. Okay. Just remember. Okay. This kind of reaction, what kind of reaction we discuss right now? We discuss electrolysis of water. Electrolysis of water. Here also, what kind of energy is absorbed, sir? Here, energy is produced, absorbed is what, sir? Electric energy. Electric energy is absorbed. Okay. Okay, next one. So this is about decomposition reactions that we discuss about next concept. Okay. So after this one, they given about thermal decomposition completed. This all things completed. That we discuss about. There is some questions are there. Uh, you can see here they given the solution of substance X is used for whitewashing and name the substance. Okay, we can discuss here. Okay. You can see here solution of X means what, sir? What it meaning, sir? Solution of X means, remember, X plus water. X plus water means what, sir? It forms whitewashing. Whitewashing means we know very well. Calcium hydroxide is used as a whitewashing. So then what is X, sir? X is what, sir? Calcium oxide plus H2. You know very well. It gives. So X will be what, sir? X will be CaO. So what is the question? Read. Name the substance X and write its formula. What is the X, sir? You should write. Name is what, sir? It is an calcium oxide. Name very very important. Okay, many times children what they will do, whatever answer they will write, but thing is CBSE want what they are asking that you should write. Okay, calcium oxide is name and then formula. You should write a formula. What is the formula of calcium oxide? CaO. Okay, again you know very well, calcium valency 2, oxygen valency is 2, 2 1 that 2, get the CaO. Okay, if you have doubt about formula. Second one, you see, write the write the reaction of X name in the above with water. So they are saying this X you should write reaction with water. You should write the reaction. X is what, sir? CaO, calcium oxide plus water. Usage towards, sir? CaOH taken twice. Okay. So this is also called what, sir? This is also called quick line. What about this one, sir? This is also called what, sir? Slaked line. Slaked line. Okay. So next question you see. Next question. You see next question is here. Why is the amount of gas collected in one of the test tube in activity 1.7? Activity 1.7 means just nothing but activity 1.7 means, remember, is nothing but what's that? Electrolytic decomposition of what, sir? Of yes. So what happens, sir, here? So name the gas collected in the one of the test tube in the activity 7. Double the amount of collected in the. Why the amount of gas collected in the one of the test? They are asking why. Why? Because what, sir? Because you know very well. We discussed that H2O is made up of what, sir? Two parts of hydrogen and one parts of oxygen. So you can write two parts of hydrogen. So you can say that's why for every one molecule of water, what's that? Two hydrogens and one oxygen is produced. This is the answer. Similarly, name the gas. Which gas is produced at double, sir? Which gas is double here? You know very well. H O ratio is 2 is to 1. Which is double, sir, here of hydrogen is double. So hydrogen is double. That's why you write. Name the gas. Which is double means hydrogen gas. Okay. Next. So come to the next type of reaction. Third type of reactions, which is displacement reaction, which is displacement reaction. Okay. So in this one, what you should know, sir? So third type of reaction you should know is very very important. Most of the question paper is contain question regarding this concept actually. That you write what you mean by displacement reaction. Before this, you should know something else, okay, or something else. Or should know what so reactivity series. Okay, this see. Let me define this one. Displacement reaction. Displacement displacement reaction. Okay, here nothing but more reactive. You can say here they know about metal, so you can say metal reactive displaces less reactive metal from where's that from its salt solution is called displacement reaction. They given ever for every example they given copper sulfate. For copper sulfate, if you're adding iron, so iron will displace the copper, will get the place of copper. So FeSO4 plus copper is reaction is called displacement reaction. You see here, this is salt solution. So you should remember they given salt solution. Why should it be salt solution, sir? Because solutions contain ions. So ions are important. Once if ions are formed, suppose U plus 2 SO4 minus 2 ions will produce, then Fe can easily send this copper outside. So you get the place of copper being a less reactive to come outside. Okay. So this kind of reaction is called a displacement reaction. So before this, what you should know to understand this one. So how will confirm this is taken place? This reaction is taken place or not? So you can see this color of copper sulfate will be blue color. Okay, and color of FeSO4 is what, sir? Green color. Now once what they will do, they will take a test tube, and you can see it even here diagram. So you can see here. Okay, you can see it. So here what they taken, sir? Here they taken the test tube is here, and they kept the iron nails here. Directly the iron nails are kept in the solution of copper sulfate. This copper sulfate solution you can see this is an blue color. This is an blue color actually. This blue color copper sulfate solution is there. Okay, this is blue color copper sulfate solution. Okay. For this blue color copper sulfate solution, they are adding what? They are adding iron nails. You can see there is an iron nails are here. Then after sometimes what happens? Sometimes, sometimes so you can see here this color. Earlier it was color was blue color. After keeping the iron nail in the copper sulfate solutions, it turns into pale green. Pale green represent formation of FeSO. That you should remember. Okay. Pale green represents what, sir? Pale green represents formation of FeSO4. Pale green is represent this one. Okay. So that you should remember. So one more thing is here. So this iron nail will be there. No? This iron nail will be this is thing like iron nail. Upon this iron nail, you can see there is an brown color coating. This brown color coating will be there. Brown color coating will be because of what, sir? Because of copper. So you should observe here. First thing is blue color copper sulfate is turns into which color, sir? Green color because of formation of FeSO4. Okay. Similarly, iron nail color is becomes what, sir? Brown color because of brown color represent a coating of copper. So copper is brown in brown color. Okay. That's why remember two colors are different results. Blue turns into blue is color of what's the copper sulfate. When we are adding the iron sulfate is formed. That can be confirmed by what you call, sir? Blue color turns into green color. That green color represent formation of FeSO4. Upon the iron nail, there is a brown color coating due to the what's that? Copper. Copper is going to deposit upon the iron. So before this one, you should know something else. Something else. You should know reactivity series. So see, to understand this reaction, you should know at least reactivity series. No, reactivity, reactivity series. So reactivity series. So what is nothing but this decreasing arrangement of uh, different metals. Suppose we have first we have potassium, then we have potassium is more reactive than sodium, more reactive than calcium, magnesium. And after we have aluminum, then after we have zinc, then we have iron, then after we have lead, and after we have hydrogen, and we have copper, mercury, silver, we have gold. Okay, so how to remember this one? You remember we have mnemonics. Please stop calling me a zebra. Instead, learn how copper, how copper mercury saves gold. Okay, so please means remember potassium, please stop representing sodium, symbol is Ne. Similarly, we have calling means remember represent Ca, then after Ca it is Ca. Me means magnesium, A means remember aluminium, then we have zebra, zinc, instead means iron, Fe. We have learn means lead, Pb. We have how means H, then we have copper, copper only, mercury, mercury only, and silver, silver, and gold is gold. So like this you can remember here. So why should this is important, sir? See, if we know this one, if we know this series, then only we can able to understand whether the reaction is possible or not. Suppose they given here. Suppose suppose X displaces y. It means should remember what's that? X is more reactive than y. This is important. Okay, X is more important than y, more reactive than y. Okay. Similarly, if they given displaces displaces x, then what should remember? Sir, should remember z is more reactive than x. Okay, so in this way. Similarly, you see next one more example I can take. Suppose if they given copper sulfate plus Ag. Here you see here the reaction is possible not. Where is Ag, sir? Here is here. This Ag and here is copper, which is more reactive than sir. Copper itself more reactive. That's why copper this reaction is not possible. We can say no reaction. You can say no reaction. Suppose if they given FeSO4. For FeSO4, if I am adding the zinc, so reaction is possible. We can say ZnSO4 plus SO4 plus iron will be formed because iron is more reactive than so on. Sorry, Zn is more reactive than the iron. Zinc is more reactive than the iron. So in this way, you should understand. So what is the meaning of reactivity series? Something but the arrangement of different metals with an decreasing order, decreasing order of reactivity. Okay, if you know these all things, then you will come to know which reaction, the reaction is possible or not possible. Okay, see some more examples we can take here. So copper sulfate, as I said already, copper sulfate plus Fe reaction is possible, sir. Definitely, FeSO4 plus copper will be formed. Similarly, copper sulfate plus silver, sir. No reaction, no reaction. What is the reason, sir? Here, remember here copper itself more reactive than the silver. Suppose we have AgNO3, silver nitrate, plus we are adding copper. Reaction is possible, yes sir, copper nitrate will form. Why? Because here copper is more reactive displacing copper, silver from silver naked. Okay. Similarly, if I taken the FeSO4, FeSO4 plus zinc, again reaction is possible. ZnSO4 plus Fe will form. So these are the things we come to know when we know about the reactivity series. This is about displacement reaction. Remember, this is most important topic. Almost all every year there is a question. Last year into 2025 also they asked first question. First question, I mean in section B, first question is remaining we discuss afterwards. Thank you for watching.